Okay, so the last lesson, I shouldn't have hit record while I just choked on my spit there. All right. Last lesson is whether a series is absolutely convergent or conditionally convergent, or it could diverge is the third choice. So you have it diverges, or it can converge absolutely, or it can converge conditionally. So if you absolute value the series and that converges, then it is absolutely convergent. Cool? If you do the absolute value and that series converges, absolutely convergent. If the absolute value diverges, but the series itself converges, then it is conditionally convergent. It's basically just a lot of vocabulary. All right, here we go. Let's do the absolute value for this one, and we're going to be good with our notation, okay? So if we absolute value, are you getting good at drawing sigma? No, okay. As long as you can tell what it says. All right, if you do the absolute value of this series, all that's going to happen is it won't alternate anymore. Do you get what I'm saying? That -1 part is going to go away. So it will just be n factorial over 2 to the n. Now, I gave you that paper that's the recap of all the different tests we've got. What do you want to try? I would do an nth term test, which involves writing a limit. Cool. So we're going to do limit n goes to infinity of this thing. And then what is that limit going to go to? Infinity. So what we get to conclude is that the absolute value of this series does what? Diverges. Okay, now before we write anything else, I'm going to try and save you some writing. If you were to do an nth term test with not the absolute value, but just this original one, wouldn't that also go to infinity? All right, so the entire thing diverges. This original series diverges. So, and that is a good question. The first thing you do in an alternating series test is the nth term test. So if we started to do an alternating series, I just didn't make you write it. We just said it verbally. Just trying to save you some writing, right? The first step in an alternating series test is an nth term test, and it would fail. It would diverge. So the whole thing diverges. Started out with an easy one. Start out with the same thing here. We're going to do the absolute value of our series. And what that means is it's just not going to alternate anymore. All the terms will be positive. And then you want to look at that and ponder, what tests do we want to try? You got a lot of tools in your toolbox. P series. So P is 1/2, which is good. Less than or equal to 1. And what does that mean this does? Diverges. So the absolute value diverges. But the original series might still converge. And it does. We're just going to prove it. All right. So if we go to do, what test should we do for this one now? The original one. We showed that the absolute value diverged, but what should we do with the original one? Yeah, alternating series test, which starts with a limit. Limit n goes to infinity of 1 over square root of n. And if n gets bigger and bigger and bigger and bigger and bigger, the limit goes to 0, which is cool. That's what we wanted it to be. And then the second thing you have to show for alternating series test is that the terms are getting smaller down to 0. So we're going to plug in n plus 1 and show that that is smaller than the series. Which, is that true? Is this going to be smaller than this? Yes. And I would never take off for this, but just in case, to be super, super thorough, let's throw that in there. And so this converges by alternating series test. So if the absolute value diverges, but the original series converges, your big conclusion to the whole thing converges conditionally. Hooray. You are all very, very good at picking which tests to do, which is often most of the battle. Go ahead.
So like when you say conditionally convergence, you have to say conditionally.
Oh, that's fine. Whatever order you want to write it in. That's not a picky thing. Good question, though. A lot of things are super picky. That is not one of them.
So for divergence,
If the whole thing diverges, it just diverges. All right, try again. We're going to do the absolute value. I think 4 is the longest one, if I'm remembering from my notes. So if you do the absolute value, you're just getting rid of the -1 part. You're getting rid of the fact that it alternates. Now, that's not a P series. Oh, I shouldn't have said that. Should have made you think about it. What do you think? It is geometric. What's R? 1/3. Good. If you want to, if you don't want to write it, you don't have to, but you can also write it like this. So R is 1/3. So we're going to say absolute value of R is 1/3, which is less than 1. Yeah. So that means that our absolute value series does what? Convergence. And if your absolute value series converges, your overall conclusion to the whole thing is that this one, the original one, converges absolutely. So it's nice when the absolute value converges because you get to just stop and say, okay, that's my answer. I think 4 is the one that has the most work. If you want to save that one for last, we'll skip down to 5. We'll save the hardest one for last. Are you just okay? We'll just chug along then. Okay, cool. I'm gonna save the hardest thing for last kind of person. We're all allowed to be different. That's fine. Yeah, get it out of it. All right. So if you do the absolute value again, all that's going to happen is it's not going to alternate anymore, right? So it will be 1 over ln n plus 1. Now, that's not a P series, and it's not geometric. So think about some of the other tools you've got available and use that little cheat sheet that I've gave. You can have it until I hand you a test. I would not want to do an integral with an ln in there. It's just me personally. I would do a comparison, and I think direct comparison is going to be the easier one. Okay, so let's compare. I'm going to compare it to just 1 over n. Close enough. Again, comparing is like close enough. And you want to compare it to something that's easy. That's the point, is you want to compare it to something that you can evaluate fairly quickly. Like we can do this pretty fast. If you do the nth term test, that limit's going to go to 0, and it's going to be no conclusion. And then you're going to go, oh, I have to pick a different test. I was trying to avoid some writing, so I'm not going to. Sometimes I will take you guys down the wrong road to show you why it doesn't work, and then we'll have to come back, but I'm not trying to do that right now. Okay? So what do you think about this one? You can either say, and does that mean it converges or diverges? So I would write diverges because harmonic series. But I was just about to say that. It's a P series where P equals 1. So you could also say P equals 1, which is less than or equal to 1. But the harmonic series shows up a lot. It's just where P is 1. Oh, there's 2 people talking to me at the same time. Hold on. It's just 1 over n is the harmonic series. That's it. It's just a special one where P is 1.
Can we just write diverges because harmonic, or do we have to write harmonic series?
I would love to believe they would not take off if you didn't write the word series. Okay. All right, now hold on. We said this one diverges. What about this one? Well, I would do a direct comparison. If this one diverges, in order to say this one diverges too, it needs to be, oh, less than. I'm sorry, I pointed the wrong way. If one of them diverges and the other is, no, it has to be bigger. No, if one of them if I'm saying this one diverges and that one's larger than it, then it's going to have to diverge too. I was right. Make me feel like I'm wrong. All right, so this 1 over ln of n plus 1, we have to show that that's bigger than 1 over n. And it will be, I promise. And so our conclusion from that is, since the one we compared to diverged, this absolute value one also diverges. So this is our conclusion. The absolute value one diverges. So we're not done. Because if the absolute value diverges, what do we still have to test? If the original one converges. So what test would you want to do for this original one? Good, alternating series test. So that starts with limit of this. And where is that limit going to go? Hey, try to focus. 0, which is good. What's the second part of your alternating series test? The terms are getting smaller. So we're going to plug in n plus 1. If you plug in n plus 1, you're going to have n plus 1 plus 1. So n plus 2. I love hearing that makes sense. That's literally my favorite thing as a teacher. That means I did my job and you did your job. Does it make sense that this is smaller than this? Yeah, if you have a bigger denominator, it's a smaller fraction. So from that, we get to say that this original series converges by alternating series test. And so your huge conclusion overall to the whole problem, if your absolute value diverges, but your original series converges conditionally. There were 3 different series going on there. There was the original one, there was the absolute value, and then there was the one we compared to for the comparison test. I was juggling a lot. I told you that was going to be the hardest one on here.
So last question, we didn't prove that the initial problem converges.
If the absolute value converges, it converges absolutely, and you don't have to do any more work.
Okay.
So that's why you do the absolute value first. If you're like, oh, which one should I do first? Do the absolute value first, because if that one converges, you're done. You don't have to do any more work. Okay. Hold on. If we do the absolute value, that's going to be this. What does the sine graph look like? It's a wave that stays in between -1 and +1. So I just left the absolute value in there. We're going to do another comparison test. We're going to do a direct comparison. So we're going to compare this to, and I want you to think of a series that would be really, really, really easy to compare. Think of something easy. P series where P is 2. The point of a comparison is you're choosing something easy. That's the point. So what do we know about this one? P equals 2, which is greater than 1, so converges. That means this one converges. So what we're trying to say is that this one also converges. So if this one converges, that one needs to be smaller. So if you have one that converges, like it goes to, like it has this leveling off behavior. If you want to say another one also converges, it has to be smaller.
And then diverges.
Correct. If I say this one diverges If I have one smaller than that, it might converge. I don't know. But if you have one that diverges, anything bigger than that is also going to diverge. It's going to keep getting bigger and bigger. All right, so our conclusion to this is the absolute value converges. And so what's your overall grand conclusion to the whole thing? Good. Converges absolutely. So you do the absolute value first, because if that converges, you're done. If the absolute value diverges, then you have to go back and check the original one to see what it does.